Students, are you able to hear me?
Yes, sir.
Yes or no? Okay. So I'll be reaching the academy in 5 minutes. Okay. Coming back from my school. Till then, keep revising the topics we discussed in the previous class. So I'll come and start.
Okay,
Okay.
sir.
We were doing problems in the previous class, right?
Yes, sir.
Okay. Now, just a minute. Yes. So last class we did vectors part, right? So this class will start the next part of this chapter, which is projectile motion. But before that, is there any doubt from the previous topics that we discussed? Do you have any doubts from the topics that we discussed? All are clear? Sure. Can I ask questions? Can I ask? Yes or no? You solve problems also. You like to. Okay. Srini, will start with you. Can you tell me what is parallelogram dot vectors? When do we use parallelogram dot vectors? We solved many problems based on it. It's not resultant. You will be able to find the resultant when the vectors are lying in a particular format. What is it? If two vectors have the same initial point, Srikriti, can you tell me? If you have two co-initial vectors, then the resultant of those two co-initial vectors is given as what is theta? Okay. So you tell me, how do you find the resultant made? How do you find the angle made by the resultant with any one of the vectors? There is a formula, tan alpha is equal to something. The resultant vector will be equal to, I asked how do you find the angle? Tan alpha is equal to So you're confusing multiple concepts. Hari Raghav? None of you have revised. You tell me. You tell me how to find the angle made by the resultant with any one of the vectors. Tan alpha is equal to, there is a formula. What is it? You know what? What is it? So which side should it lie for it to become b sin theta? See, for example, if I give you two vectors like this is a vector and this is b vector. Okay. The resultant is like this. Then if this angle is theta, then what will be the value of tan alpha? Sorry, if this angle is theta, if this is taken as alpha, then what will tan alpha be? Is it still b sin theta by a plus b cos theta? Why? Yes, because if you see the derivation, I would have told alpha is taken here. So when alpha is taken here, then what will tan alpha be equal to? It will be b sin theta divided by a plus b cos theta, right? Whereas here, what did we do? We reversed it. Suppose instead of alpha, if I take it as tan beta, then what will tan beta be equal to? A sin theta divided by b plus a cos theta. So this is how it works. Are you able to understand? So one last concept left out with respect to vectors is resolution or components of vectors. Okay. There is a vector A like this, right? If I take the angle to be theta here, okay, then this A vector can be broken into two perpendicular vectors. What are you doing? A vector is broken into two perpendicular vectors. So how are those two perpendicular vectors broken as? One will be A times something, and here it will be A times something. Here, noted, this will be A cos theta, and the perpendicular component will be A sin theta. So observe, if this is a vector and the angle is included here, okay, wherever the angle is, the side opposite to that angle is what is called as A cos theta, and the side opposite, side perpendicular to the angle will be called as A sin theta. Is that point clear? Then this A cos theta is what is called as the horizontal component, and A sin theta is what is called as the vertical component. Is that clear? So make a note of these two, and these two components are also called as rectangular components. So you call them as rectangular components because you break them into two perpendicular sides, which are representing the sides of a rectangle. Is it clear? This is a very, very, very important concept because going forward, whenever you have a vector and the angle made by the vector with any one of the directions given to you, there might be in most of the scenarios, you have to break them into their respective components and then solve the problem. Okay. So let me make you understand this. If suppose this is a vector, okay, and if I take this angle t theta, then it can be broken into two perpendicular vectors. So at the same point, you will break it into two perpendicular vectors, where one perpendicular vector in this case will be what? A times, observe, it will be A cos theta, because what did I say? The side adjacent to angle will be written as cos. The side opposite to angle will be written as sine. Are you able to understand this point? So it will be broken into two components like this: A cos theta in the vertical direction and A sin theta in the horizontal direction. Okay, make a note of this. So another important point to be noted is, depending on how the vector is oriented, you need to know what are the two rectangular components into which you need to break them. If you observe this direction, right? If you observe the direction in which it is there, you take the initial point as the origin and draw a reference coordinate system like this. When you draw it in this way, this A vector is getting diverted into which quadrant? It is going into the fourth quadrant. In the fourth quadrant, what is positive and what is negative? So x is positive means A. If I take this angle to be theta, x should have a positive vector and y should have a negative vector. So what are the two components? One will be A cos theta here, and this will be A sin theta. In a similar way, if I give you a vector like this, okay, which is also A, and here I say this is theta, break it into its corresponding rectangular components at a. When you break them with respect to components, so the horizontal will be in this direction, left or right. It is entering into which quadrant? Second quadrant. So second means left hand side and upwards. So left hand side will be a cos theta and upwards will be a sin theta. That's very, very simple, right? So based on this, we are ready to start the next part of this chapter, which is called one proof, right? Say this is a vector. Let me call this as A. Okay, its magnitude is going to be A. So if I draw it in this way, if I take this to be theta, then when I drop a perpendicular from here, it forms a right angle triangle. So if I take this as y and this as x, what is x by A equal to? So x will be equal to, and y by A is sin theta, which implies y will be equal to A sin theta. See, wherever sin and cos are coming, simple logic is, if you want to prove something, first construct the right angle triangle and then proceed. That's it. You need not think anything outside. Okay. So I hope you understood. If this is A sin theta, then I can write this also as A sin theta because they both will become equal vectors. So if I put an arrow mark like this, an arrow mark like this can also be put. Is that point clear? So if you see this concept, it is exactly the reverse of what we did in parallelogram law of vectors. So for parallelogram law of vectors, you had two co-initial vectors which were inclined to each other at an angle of theta. Then what would be the resultant? R will be root of a square plus b square plus 2ab cos theta. Is that clear? Now what are the two vectors that are there? A cos theta and the other one is A sin theta. Are they co-initial vectors? Yes. So the resultant of it will be something like this. If I call this as R, then R is equal to how much? Root of A square cos square theta plus A square sin square theta plus 2AB cos. How much is the angle between A cos theta and A sin theta? 90. So cos 90 is going to be 0. So root of A square cos square theta plus A square sin square theta. Root of A square, which is A. Means if you already know the resultant vector, you're trying to find this resultant vector is the resultant of which two vectors? It is the resultant of A cos theta and A sin theta. You're finding its corresponding input values. Are you able to understand? Is that clear? Clear or not? So make a note of this. This one. This one. Idwa. This is A. Root of A square is A. How did I get root of A square? Root of A square is what? A, no? So what is A? This one only. No? That A vector is the one you broke it into A cos theta and A sin theta. So if instead of giving you the vector A and ask you to break it into two components, if I give you A cos theta and A sin theta, can you tell me the resultant? See, what does parallelogram law state? Were you there in the previous class? When I was solving problems? You were there? Okay. So in that, what did I tell you? If you have two co-initial vectors and you know the angle between them, you can always find the resultant of them by using the formula root of A square plus B square plus 2AB cos theta. I did the same thing. Root of A square cos square theta. A is A square A is A cos theta, B is A sin theta, so A square sin square theta. So if I take out A square common, cos square theta plus sin square theta is 1. So that's the answer. Shall I proceed? So write down the next setting as projectile motion. So what do I mean by projectile motion? So let us say there is an object here which is projected neither completely in the horizontal direction or completely in the vertical direction. Answer this question to me. If I give you a particle and I ask you to move this particle in the horizontal direction, what will you try to do to it? You will give it a horizontal velocity and it starts traveling completely in the horizontal direction, right? Similarly, if I ask you to project it vertically, what will you do? You will give it a velocity in the upward direction. It starts traveling in the vertically upward direction. It will go up and then come down under the influence of gravity. As of now, we are assuming that the object is traveling only under the influence of gravity in vertical direction. Okay. So you're neither projecting the particle completely along the horizontal nor completely along the vertical. Then what will happen to this particle is what the question is. So if you translate it either, means if you project the particle either completely horizontal, it is going to have a straight line motion. Completely vertical, it will have a straight line motion going up and coming down. Whereas when you project it at some angle theta, then what will happen? That is what we are going to see. So just now we learned the concept that if you have a vector which is making an angle theta with any one of the directions, then wherever the angle is there will be u cos theta, wherever the angle is included is u cos theta, and the opposite one will be u sin theta. So u cos theta will try to push the particle in horizontal and u sin theta will try to push the particle in vertical. So neither of them will be able to completely succeed, so that the particle will neither completely move along the horizontal nor along the vertical, whereas it starts moving along this kind of a path, which we call it as parabolic path. Are you able to understand? So it starts traveling in this kind of a parabolic path where the particle will be able to attain maximum height. The particle will have a maximum horizontal distance traveled by it, which we call it as range. And it takes some time to go from point A to point B. And the time is what is called as time of flight. So these are the three important parameters associated with respect to a particle which is projected at an angle theta with respect to the horizontal. And in this context, we are going to find out what those values are. Is that clear? So make a note of this diagram first. Range is horizontal, maximum horizontal distance traveled by the Shall I proceed? Yeah. Now see. Here, I'm going to prepare a small table. First one is velocity. This is x and y. So I'll call it as initial velocity. So what is the initial velocity along x direction? It is u cos theta. And the initial velocity along y direction is u sin theta. Accepted? Similarly, if I talk about the acceleration, if you observe in the horizontal direction, there is no air drag or viscous force. So viscous means resistive force. Okay. So in the horizontal direction, if you observe, there is no force acting at all. When the force acting is zero, acceleration along x direction is completely zero. So particle is not changing its velocity along the horizontal direction. Whereas in the vertical direction, who's trying to pull the particle down? This gravity. So in the vertical direction, it is going to be acceleration due to gravity, which I'll call it as G. Okay. Now we'll give the sign convention to it. U cos theta. So for sign convention, I need to have a basic reference system. Positive, positive. Left hand side is negative. Downward side is negative. Okay. Now having said this, if I want the particle to move in the positive direction. So, sorry, if you see the initial velocity, is it in the positive direction or negative? So this is positive. U sin theta, 0, no sign. What about G? So G always acts in the downward direction. Whether the particle is going upward or downward, G is always in one direction. So G is negative in this context. Is that clear? So I've written the sign convention also, make a note of this point. Shall I proceed? Now see. We will be calculating three parameters. One is maximum height, range, and TF, which is called as time of flight. So first I am starting with maximum height. So first of all, what do you mean by maximum height? Name itself is suggesting the maximum displacement of particle in which direction? In y direction. So maximum displacement of the particle in y direction is called as maximum height. So to calculate this, what you will do is apply v square minus u square is equal to 2as along the y direction. Okay, means you will take all the values of final velocity, initial velocity, acceleration, and displacement only along y direction. Okay, so when the particle has gone from bottom to top, particle has traveled in the upward direction. So if this is called as the displacement, which I'll say h max, is h max positive or negative? Okay. So at the maximum height, what is the vertical component of velocity? It is 0. So 0 square minus, what is the initial velocity along vertical direction? U sin theta. So U sin theta square is equal to 2 into, what is the acceleration along y direction? You have the table. Minus G into displacement of the particle along y direction. How much is it? H max, no? Because what is the kind of scenario you are trying to define? You're saying when the particle has gone from bottom to top, it has traveled a displacement of h max. During this process, initial velocity was u sin theta and the final velocity was 0. So you substituted all the values here so that you get minus u square sin square theta is equal to minus 2g into h max. Minus and minus will get cancelled, which implies h max is equal to u square sin square theta divided by 2g. If you're done with this, let me know. You're done? Ashwin, you're done? So next is for time of flight. So time of flight is TF. Okay. So for time of flight, I'll be applying S is equal to UT plus half AT square. This also along y direction. So displacement of the particle along y direction is equal to initial velocity of the particle along y direction. For time, you will not put y because time does not have direction. Plus acceleration of the particle along y direction. So when the particle has traveled from point A to point B, how much is the vertical displacement suffered by it? How much is the vertical displacement suffered by it? How much? Between point 0 to B. So if the particle has gone from point 0 O to A, between O to A displacement is h max, but between O to B, what is the vertical displacement? It's 0. Means the particle wherever, whatever horizontal level it has started, it has landed back at the same horizontal level. So along the vertical direction, the displacement of the particle is 0. So this is 0 is equal to uy is how much? It is u sin theta, that's what the table says, into t plus half into acceleration of the particle along y direction is again minus g into t square. Am I clear with this? So first listen, then you can write it. So 0 is equal to, if you observe this, isn't it a quadratic equation in t? So I will take the t outside, t into u sin theta minus g by 2 into t is what is 0. So I'll get two values of t, which implies t is equal to 0 or u sin theta minus g by 2 into t is 0, which implies t will be equal to 2u sin theta by g. Is it right? So why am I getting two values of t? So here, what do I mean by t is equal to 0? T is equal to 0 implies the vertical displacement of object is 0. So if you observe the whole diagram, right, there are 2 points where the object is lying on the x-axis itself. Where are the 2 points? One is at O and the second is at B. So that O is the time which corresponds to t is equal to 0. And B is the time that corresponds to 2u sine theta by g. And this 2u sine theta by g is what we call it as time of flight. Is the point clear? So make a note of this. Those who are online are able to understand.
Yes, sir.
Shall I proceed? Right. Done. And the last one that you need to calculate is horizontal range. So R. So horizontal range is maximum distance traveled by the particle in horizontal direction. Okay. So how much is that? When you go from O to B, the distance OB is what is called as R. So for this, what you will do is you will apply S is equal to UT plus half AT square along X direction. So Sx is equal to Ux plus half into Ax into T square. So what is the displacement of the particle along X direction? It is R is equal to initial velocity of the particle along X direction is U cos theta. And how much is the time taken by the particle to go from point O to point B? It is the time of flight plus half into acceleration of the particle along X direction is 0 into time of flight square. So this parameter is lost. So what will you have? R is equal to U cos theta into what is the time of flight formula? We just derived it. It is 2U sin theta divided by G. So here U and U will get multiplied, becomes U square into 2 sin theta cos theta, the whole divided by G. So what will it become? U square into 2 sin theta cos theta is sin 2 theta divided by G. And this is the formula for horizontal range. Sin theta cos theta is sin 2 theta. You know this or? Hmm? Copy it. So you know this, right? Sine of a plus b is what? Oh, your angles have not. This you didn't start with, right? This has been started. Huh? So sin a cos b plus. You know this, right? How many of you don't know? Have not seen it all. Huh? Okay, no problem. So sine of a plus b is sin a cos b plus cos a sin b. So what you can do is if a is equal to b, then you will substitute it here. Then it become sin 2a is equal to sin a cos a plus cos a sin a. So what is it? 2 times sin a cos a. Are you able to understand? So that is why in the range formula, if you see 2 sin theta cos theta, I replaced it with sin 2 theta. See, it's very simple, okay? For example, you know what is sin 90? What is sin 90? Sin 90 is 1. So, sin of 90, can I write it as sin of 2 into 45? If I call this 45 as theta, is this not looking like sin 2 theta? So, how can I write this as 2 sin 45 into cos 45? So, 2 into what is sin 45? 1 by root 2. Cos 45 is 1 by root 2. So, 2 into half. It's the same logic. The reason why I use 90 is because you'll understand it. It's not this simple. Like, see, for example, you want to find sin 120. Last class, I did a problem, the cos 120. You remember cos 120? We saw. We got an answer for one of the problems. If cos theta is equal to minus half, theta is equal to 120 degrees. So, for example, you have sin 120. If I'm asking you sin 120, you directly don't know the answer. So, how will you solve it? You can write as sin of 2 times 60 degree. This will be 2 sin 60 into cos 60. So, 2 into sin 60 is half. Cos 60 is root 3 by 4. So, it will be root 3 by 2. So, I wrote it in reverse. But anyway, the answer is the same. Root 3 by 2. Are you able to understand? So, it will be helpful in this way. Because I saw in the last class, in your math class, you learned about how to convert angles to radians, right? And that's what I saw in your video. Next step will be this thing, you will understand. Clear? But yeah, this basic is a little bit needed for you to solve the problems. Don't worry, at that point I'll explain. Okay. Shall I proceed? Next is range is maximum at what angle of projection? Means observe. X-axis, Y-axis. Okay, first concentrate. If I project the particle with the same initial velocity, okay, but I'm projecting at different angles with respect to the horizontal. So let me call this as theta 1, let me call this as theta 2, this as theta 3, keep on going, right? So like this, if you project the particle with the same initial velocity, means you're not changing the velocity, 10 meter per second or 10 meter per second, okay? But you're trying to project with different angles with respect to the horizontal, then they're asking what should be that particular angle where I can say range is maximum? In the sense, if I project the particle at an angle theta 1, let's say I'm getting this to be range. Let me call this as R1. Similarly, when I project it at theta 2, let's say I'm getting a range like this. Let me call this as R2. If I project it in this way, let me say I'm getting it as R3. It's just a rough diagram, okay? So like this, I have only 3 scenarios. But if I have infinite set of data in my hand, out of that infinite set, what is that particular angle at which I can say the horizontal range is going to be maximum? This is what we are going to find. Is it clear? So for that, logic is very simple. R is equal to u square sine 2 theta divided by g. What is expected? R should be maximum. Here, who is deciding the value of range? U square is a constant because u is fixed. Whereas sine 2 theta is there, right? The sine 2 theta keeps changing as you keep changing the angle of projection. Accepted? Right? So for my R to be maximum, I can conclude that my sine 2 theta should be maximum. So when is sine maximum? So sine is maximum when the angle of projection is 90. So 2 theta is equal to 90. Then what should be the value of theta? Means if you keep the velocity constant and project the particle at different angles, when you project it exactly at 45 degrees, the range will be maximum. I'll show you all those things. I'll show you, don't worry about it. But are you able to understand the concept of it? Right? Please make a note of it. So what did I say? When the particle is projected with the same velocity but at different angles, for the angle of projection is equal to 45 degrees, the range is going to be maximum. Make a note of it. So next is range is same for the particle projected at the same velocity but at complementary angles. So the meaning of it is, if this is x and this is y, it is projected with the same initial velocity u and u. If I say this angle is theta, and if I say this angle is 90 minus theta, then both the angles are said to be complementary of each other. Okay, that's not possible. So, if that is the case, then whatever is the horizontal distance traveled by particle in situation number 1 will be the same horizontal distance traveled by the particle in situation number 2 as well. Is that clear? Is it clear? But what is changing? If you see, the maximum height is changing. I'll show you something. Once you have done copying it, let me know. Okay. So, see here, it's like a small game. Okay. So, you're able to see this projectile, right? Now, I can keep it at any angle I want between 0 to generally, it's not going below because the base is not supporting. That is how they have designed it. But you can keep it between 25 to 90. Okay. So, see. Suppose this, let's say I'm projecting at 30 and I kept the initial speed at 18 meter per second. You have to see the initial speed is kept as 18 meter per second. Now let's say I'm projecting it where the air resistance is 0 and gravity is 9.81. See what is going to happen. Where is the cursor? It went and hit right. So I'm keeping the same horizontal velocity. I'm not changing the initial speed, but I'm turning this to an angle 60. So what it happens here? Look at the horizontal range. The horizontal range is the same, whereas the vertical height has changed. So that's what I meant by the last point. What did I tell you? If you keep the speed constant, but if you project the particles at complementary angles, theta and 90 minus theta, then what will happen to them? The range will be the same. Okay. So you understood that this is the scenario. Now I'm going to reset it. I'll reduce the speed. Okay. My cursor has become so small. Okay, let's say I'm projecting it at some 8. Okay. Now I'm taking random angles and I'm going to project it. So 25, you saw where it fell. That is because the initial speed is very less. Let's make it as let's make it 15 or 14 for it. Okay. So I'm projecting it at the same speed. Right? One range. So you're able to understand this depending on the angle. Depending on the angle, the horizontal range is changing. Like this, it is my wish. I can project it at any whatever angle I want. But if you see, if I take this to exactly 45 degrees and I project it, right? Is it not crossing every other value? Is it not crossing? So it is crossing every other range. Means this beyond 45 means apart from 45, you try for whatever angle you want, provided you don't change the speed, you cannot increase the range. See 48, I take it, project it. So it is almost close. Actually, if you zoom and see, it will be slightly different. So what is the maximum? It is exactly 45 degrees, provided the air resistance is not there. That is what I meant by the second point. The first point, I think. Range is maximum when the speed is not changed, when the angle of projection is 45 degrees. Is it clear? So looking at this, are you able to recollect any game that works on this principle? Which one? Short put, okay. That is also parabolic path. Come out of your playground and go to. That is what I was explaining. Angry Birds. And this is also right. Angry Birds is not the game. So when you would have played it, right? When you pull it backwards, it will show you a trajectory. It will tell you whether you will hit the target or not. So the trajectory's path, if you see, right, it is actually a parabolic path. That is also a projectile. Everything. Whenever you project anything at an angle with respect to the horizontal, all are parabolic path, all are projectile motions. Clear? So this is this is how they want to hit a target, right? They'll fix that projectile at a particular angle and then release it so that it will go and hit the target. It's used in wars and all those things. Right. I don't know where my cursor is. Right. This is all about the projectile. Of three different parameters related to the projectile motion. Here you will not get negative because the angle is acute now. Sine is negative only in the third and fourth quadrant. Is it clear? So the next question is, equation of a projectile. So you saw that the projectile travels in which path? In a parabolic path, right? So we are going to write the mathematical equation for the parabolic path, for which I'm going to start with the same u, and this is going to be theta. Okay, if I take a point P here, which is x comma y, this is x and this is y, right? So because if you have to write something in terms of physics, you will always involve time. If you have to write something in terms of mathematics, you will always involve x and y. So if I drop a perpendicular here, then the distance from the origin to the foot of the perpendicular is x, and this distance is y. Is that right? So if I call this as OM and P, OM is x and OP is y. Is that right? Now, if I say at time t, the particle is at t. Okay. So applying S is equal to ut plus half at square along x direction, what will we get? Sx is equal to ux into t plus half into ax into t square. Is that right? So what is the displacement of the particle along x direction in time t? Is there a bit of your eyes? What is the displacement of the particle? B. Displacement. What is the displacement? It's there in front of your eyes. It is x. X is equal to, what was the initial velocity that you gave? Check the table. U cos theta into t, u cos theta into t, plus half into acceleration along x direction is 0 t square, which implies t will be equal to x divided by u cos theta. So it's very simple. This is gone, 0. So x is equal to how much? U cos theta into t. So what will be the value of t? X divided by u cos theta. So let this be equation number 1. First I'll complete, then you can write. Similarly, if I apply S is equal to ut plus half at square along y direction, then what will I get? Displacement of the particle along y is y. Y is equal to, what is the initial velocity of the particle along y direction? U sin theta into the time is t plus half into acceleration of the particle along y direction is minus g into t square. So y will be equal to u sin theta into, what is the value of time? This time we derived. Time is what? That is time of flight. it is x divided by u cos theta, because all this is happening at the same instant t. So what we are trying to do is we are trying to individually calculate what is happening along x direction and what is happening along y direction separately and mix them. Okay. So u sin theta into x divided by u cos theta minus g by 2 into x divided by u cos theta the whole square. So u and u will get cancelled. Y will be equal to x tan theta minus g by 2 into x square divided by u square cos square theta. Are you guys clear with this? So this expression y is equal to x tan theta minus gx square divided by 2u square cos square theta is what is called as the equation of projectile. It's called as the equation of projectile. Why I call it as equation is because it is purely in terms of x and y. There is no physics parameter involved in this, except initial velocity and acceleration due to gravity. You don't have time at all. Is it clear? See, for example, when you had b is equal to u plus at, you call this also as an equation, but there is the equation of motion, whereas this one is equation of projectile. And one important point I would like to mention here is, if I have ax square plus bx plus c, what is this? This is a polynomial. And what kind of a polynomial is this? It is a quadratic polynomial. So for quadratic polynomial, you have two kinds of graphs. One is a graph upward parabola and a downward parabola. You will have an upward parabola when a is greater than 0. Means the coefficient of x square should be greater than 0. Whereas if the coefficient of x square is less than 0, you will have a downward parabola. Now observe the diagram. So two things I want you to compare. X square is there. What is the coefficient of x square? Negative. So that is why if you look at the graph that we drew, it is actually a downward parabola. Are you able to understand all these points? So make a note of it. Right. If possible, take 2 minutes time, observe, grasp it, and write it on your own. That is the best way to learn. It takes time and write. Both are low. TV also you get certain sudden. Which one? No? Oh, same mistake. Every time I do this. When while I recorded video, I made this mistake. I had to put editing. I had to put OPIC Vela PM again. This PM, right? Is this slide over? Should I show you the next one? You're copying it, Tada. You're done or not? Okay, shall I move on to the next one? Copy it. Done. Did you make a note of this point as well? When you have a polynomial, if the value of a is greater than 0, it will be an upward parabola, and the value of b is less than 0, it will be a downward parabola. So here you are getting a downward parabola because the coefficient of x square is negative. This almost brings us to the end of projectile motion. There is one equation I teach you. Generally, it is not taught in CBSE, but it is only 3 steps. Where, if there is a range given to you, can be anywhere. If it is like this, the parabola can be like this. It 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 can be anywhere. As long as the curvature is like this, it's a downward parabola, irrespective of where it is. Upward or downward? Because you use like this. Okay. They are equations of project. They are not, that is not the equation of projectile. That H max is an expression for mathematical expression for calculating H max. It's like a tool. See, whenever I say an equation, right? Ax plus by plus c is equal to 0. This is a mathematical equation. So here equation of projectile represents a mathematical equation. It is not a formula. Okay. So y is equal to x tan theta minus, but this expression you need to remember because this will help you solve many problems faster. Y is equal to x tan theta minus gx square divided by 2u square cos square theta. So y is equal to, if I take this x tan theta outside, observe, I can write it as 1 minus gx square divided by 2u square cos square theta into, what should I compensate with? That is x tan theta itself. So x and 1x is gone. So this will be x tan theta into 1 is 1 only minus gx divided by 2u square cos square theta into tan theta is how much? Do it in mind and tell me. Tan you can write it as sin by cos. Hey, mind la panna, you're using book. Hey, no book. Cos square theta into tan theta. You will have, see, tan is sin by cos. Left side you have cos square. One cos will get cancelled. Cos theta into sin theta. Convinced? Convinced or not? Puriyada? So this will be equal to x tan theta into 1 minus gx divided by, what is 2 cos theta sin theta? Can I write this as u square sin 2 theta? See, what is the formula for range, guys? U square sin 2 theta by g. Then what is the formula for 1 by r? G divided by u square sin 2 theta. So g divided by u square sin 2 theta, I can write it as 1 by r. Seriya? So it will be x tan theta into 1 minus x divided by capital R. So this is another way of expressing the same equation of projectile, but instead of using, expressing the same equation of projectile in terms of range. So suppose in a problem, they have directly given you the range and the x coordinate. Then what you can do, you can obviously use this formula. X tan theta into 1 minus x by r. You know the range. Why do you want to sit and waste your time in the u square cos square theta? You can directly use it. Right? So those who are online are able to understand?
Yes, sir.
Good. So listen. So is it holiday tomorrow for everyone? Yes, sir. You have school, right? What about you? What time school? But what time does your school get? You have school, huh? Okay. What time does your school get? 3 huh? Can we have a pre-con class tomorrow? In the sense, instead of 5:30, can we have it somewhere around 4:30? Will that work for you? No struggle, no. Yeah, 4:30 you guys come off tomorrow. So those who are online also, I am assuming that it's a holiday tomorrow.
Yes, sir.
Abhinav, Naveen, Ganesh,
Yes, sir.
it's a holiday, right? So listen to me carefully. Tomorrow we'll have it at 4:30. Okay. And first, I would say in 30 minutes, I want you to write a test on all these derivations. It is very, very, very important. Okay. So I will practice and come for tomorrow's class. So first half an hour, write down the derivation. And the next 1 hour, I'll teach you the next part of this chapter, that is dot product and cross product of vectors. Is that clear? So along with this, I want you to revise parallelogram law also. It was completely disappointing me today when you guys were not able to answer. So revise parallelogram law of vectors. So from parallelogram law till this expression, I'll give you only 30 minutes time. Okay? Is that clear? So practice.
Sir, 4:30 to what time, sir?
4:30 to 5 you will have this test, and from 5 to 6 I'll take class.
Okay, sir.
Okay. But maintain sharp timing. Okay, I'll inform the staff 4:30 you be here, because if you come late, you will not get extra time. Then don't ask me. I want to understand how much has gone into your mind. Better be here by 4:20 or 4:25. 5 minutes, relax and revise, and then 4:30 sharp start writing the test. Is that clear?
Okay, sir.
That's it. These are the two important equations. And everybody has a study material, right? Revise it from there, that will help you. Sure. Okay, we'll wind up this.
Thank you, sir.
So I'm ending the session. You can leave. Yeah.